Hi, this is Bits and Pieces, the official podcast of Component Supply. I'm Kristin.
And I'm Mark.
And today we are going to have the awesome privilege of talking to Damian Carr, who is an expert, thought leader, educator, all things minimally invasive device. He's with us today to talk about tapered mandrels, background, all sorts of things. Damian, thank you so much for being here.
Thank you very much for the very honorable intro. It is an absolute pleasure to be here and very exciting.
So, Damian, I was a little late to the party, I think, getting to know you. I'm not going to say I thought I had discovered this awesome thing, and then I realized everyone knew who Damian Carr was. But how I found out about it, it's my favorite post that you put on LinkedIn, and you said the Catheter R&D Handbook is finally here. That was the first post of yours that popped up like organically for me. And it was a long post about, all these years in the making and that it was your life's work. And I think for Mark and I both, when we hear someone say something is their life's work, they've got our attention, because I read that post and I'm like, man, he's in the same industry as us, has the same passion that we share for the medical device industry, and we haven't met each other. What a bummer. So I reached out and you're so gracious to talk to me. Would you talk to us about your start in the medical device catheter development industry?
Absolutely. Although I'll have to go a few years before that to where I started with the whole idea.
Yeah.
So by the age of 6 years old, I knew exactly what I wanted to do in life. Between some playing with Legos, building furniture, and I remember even arguing with my parents or trying to get power tools, which they wouldn't give a 6-year-old. I had to wait until I was 7, unfortunately.
Good parents.
Which held me back a year. But from that point, there was a cereal that had this inventor on the back of it, and it was like a chocolate cereal. I didn't even really like chocolate, but I just wanted to support what this man was doing. And I said, from that age, I wanted to be an inventor. Then when I got to 11, I ended up getting diagnosed with tuberculosis. It was something that was on our farm at the time with a lot of cattle. Transferred over to me. By the time I had found out I had it, it had somehow cured itself, but I was missing the bottom right half side of my lung.
Oh my gosh.
So overheard that I'd have a short life expectancy of 50 years, but being nonverbal at the time, parents didn't know how to come and say that to me. So they just swept it under the carpet. And I remember looking around the hospital and thinking, this is really easy stuff. It's just plain see-through tubes and white boxes. There's not even too much detail to the designs that they're doing. So I had this simple belief that when I grow up, I'll just make something to fix myself. So ended up growing up, became a product designer because it was the closest thing to being an inventor, and then went straight into the medical device world. And I'm lucky that I was born in Galway in Ireland. So I was on the doorstep of where the medical technology world was growing here in Ireland.
Yeah.
And then ended up just traveling around from company to company, mostly contract manufacturers, with an absolute thirst and hunger to figure out more information on how these devices are built. And then before I even knew it, I had learned possibly a little bit too much to contain in in my own head.
Yeah.
So I ended up starting doing workshops, teaching other people about the devices, the technologies, the materials, who you can go to, and just demystifying that little bit of an overwhelming path for R&D engineers and similar. And it just kind of blew up from there.
Huh. That's amazing. If I remember correctly, you call them complicated straws. Is that right?
Complex straws.
Complex straws. Yeah, I love that. Like it's not that hard. It's a straw. It's just a little tricky.
Right.
Just a little tricky, and each straw for each purpose. And then it has actually come around in full circle, because yesterday we delivered our first, what is called Seeds of Life Sciences program, where I went into high schools teaching them about medical devices, the routes they can go to, the jobs they can take, and then the courses they can do in college and subjects they can choose in school. So this is something that we're rolling out for free and hopefully trying to get all across Ireland over the next number of years. And that is the whole reason it all started. The adults just get to enjoy some of the benefits of it too.
Yeah, I love that. We really have a heart for investing in high schoolers, particularly. We have a partnership with our local high schooler and have had several workers come through. We have We have Tennessee Tech University is in our town, and so one of our interns now started at high school, college, and like I hope he stays forever.
Sure.
He's just
me too.
Great to have. So when was your first workshop? When did you first start doing this?
My first workshop was July 2021, I think, was the first official one. I had been doing small ones prior to that, and then for the first 3 years of that and a couple of years beforehand, it was all word of mouth.
Did it take
just people who I'd work with?
Did it take a long time to get like traction? Were people like, who is this guy coming to our town to do workshops? Or was it just took off?
Everything was word of mouth. It was just people who I'd worked with. I had worked on over 150 devices before starting up the workshops itself. And then when companies would reach out looking for consultancy, I'd respond with, can I just teach you how to do all this yourself and then you'll never need me again?
Yeah. That's the thing, right? For you, it's like you can teach, give the guy a fish or teach him to fish, right? And that's what you do. And you big advocate of open sourcing, getting all the secrets out. Let's tell people how we do this stuff so they can do it on their own until they get big enough really to outsource it, because at the beginning, it's just, you just need one. Sometimes you can do it yourself. It doesn't have to be perfect.
And I've always loved the idea of working myself out of a job.
Oh, yes. Oh, man, y'all. Mark's always telling me I need to work myself out of a job. I love that. I love that concept. So you have this unique perspective because you're seeing this kind of a finished catheter design concept with the workshops. You're kind of beginning to end catheter design. Component supply, we just have a very, very small part. And, we sell a lot of supplement auxiliary kind of components, but we're a hypodermic tubing and wire supplier and fabricator. And so we really see only the challenges with that one component. And we'll get into that. Can you speak a little bit to the challenges you see when you're going to leading these workshops and meeting with engineers and product designers? What are kind of some of, maybe at a high level, some of the main challenges that you see regularly in design?
So the comfort of habitualization. So if you've developed a device and you've been producing it in one way, your next devices will more than likely take around 80% of that existing device and then maybe add any new features and benefits. Mm-hmm. So we tend to stick to what we know. And engineers in general, we're very risk-averse people. So the idea of adding new technology, new equipment, new materials can be a little bit overwhelming if you don't know the output. Mm-hmm. So it's simply just taking away the veil of that so that you have enough confidence to know that if you try in a certain direction, that you could have 80% success, 90% success, and be able to follow it through. And then the other side, the big problem that even I had, and I'm the world's most guilty person at this, is I could prototype you 10 or 20 devices. That's no problem. I will do it in any way I can see fit. But passing that off to production to get that mass produced, a very different story.
Is that just like wanting to hold the project close and not wanting to, or just finding that person to scale with you?
It's the skill set that it requires and the tools that you would use to do those first few builds.
Yeah.
In a small lab versus if you want to control this and rather than one person who knows every little step and if something goes wrong, how to balance it, to moving this to 20, 40, 50, 100 people on the line where it's broken down into individual single steps.
Yeah.
So I work very well in chaos, but manufacturing is not designed for chaos.
Yeah, you could speak to that probably a little bit.
That's a big part of it is understanding there's a shift between kind of the designer. Then you've got tool makers, and many of the designers, or at least they used to be, had a tool maker mentality and had the skill set. So they would make the tool to make the thing. Sometimes they'd make the tool to make the tool to make the thing, and then it worked wonderful. And then you kind of brought it into like a machine shop, and they said, okay, but that's wonderful, but that tool is actually six different processes now, and so we need to break this down. And that handoff, Damian, you're right, is very difficult because it's typically not found in a company, those processes. It's generally not found in a contract manufacturer because you're really talking about different, just kind of dissecting something to bring the manufacturability. Getting someone involved early that can say, well, we're good at this. And this is where you talk about kind of collaboration, right? Because that process might be 3 different companies' skill sets. And it may end up being, one company that does it, but to go from the designer to the manufacturer might take 3 different contract manufacturers in a course of time to get those processes down to be able to produce it at scale. And that is a difficult process. I think it was easier years ago. I feel like we collaborated more and kind of got all on the same page. But it is a challenge, more and more of a challenge today.
I think Damian's bringing that back, though. Like, I think with the workshops you're doing, having so many different people from different organizations coming in under the same idea, like you bring back some of that collaboration. I think that you saw early on in your start in the industry. So that's been cool to see, comparing what you're doing to what he was seeing earlier, like before I started on.
Absolutely. And when Mark was starting, you could actually meet the person and talk face to face with them. And so much more can happen now that there's more opportunity, but it's globalized. So you only get it in touches and feels through web calls or sending over specs. Right. So there's a loss in translation there.
Mm-hmm. Yeah.
But hopefully we're bringing it back. I think medtech is an industry that is ripe for growth.
Yes.
Mm-hmm. And if we were able to bring 20 or 30% of the entire world's population into developing medical devices, I think the world would be much better for us.
Yeah.
So,
it's interesting you brought up some of your, I go back in the history of kind of my background, what I was used to, and you talking about your story. So many, when you look at the devices that, in their infancy, if you peel the layers back, there was someone, whether they were an engineer, whether they were a doctor, or whether or not they were, a patient, who experienced something and then had a passion to get behind it and figure out a solution. And with that, you would find someone that would find a solution. They would make it a product, a process. It didn't matter. And yes, it was a business, right? But the reality is what they found was a solution, and they wanted. It's sort of like the scientist side, right? You were talking about engineers, and some of this we need a combination of engineers and scientists, right? So the scientist makes a discovery, they share that discovery. They're not trying to hide it or do anything with it. They're sharing it because they want other scientists to test that theory and either confirm or refute, and then from that they can then use, in the medical device industry, the person who found it is saying, hey, I found this, it worked for me. Can you use it to help your people? It was, go out and use it. Go find someone else. Let's make this place a better world. Mm-hmm. And they weren't really worried about, not that they weren't worried about patents or things like that. That always existed, but they weren't really worried about like this was our design or this was our device, because they were smart enough to come up with the next one, right? They were going to come up with something different. And if it could help, if they helped 100 people with it and they shared that with another 100 people, it just kept growing, and we were helping more and more people. That spirit. When you were talking about your story, that's what I was so used to. That's what made me fall in love with this industry was this. We all had businesses. We were all trying to run our businesses well. But the bottom line is we knew that there was someone at an operating table. That's why we were doing it every day. And so your story just really does resonate with me. And some of the things that you're putting into practice through, I want to say your workshops, but really just your person as a person. It really does resonate because it brings that original spirit back that I think existed in the early stages of really, really innovative device manufacturing. And then again, they had the same challenges. How do you scale it? Because now we've got thousands of people that need it. And so how do we bridge those challenges?
And you touched on something very interesting that I've noticed. So if you go back 100 years, when you go into a town, you'd find people working, and there'd be the baker, there'd be the blacksmith, there'd be the carpenter, and they lived with that identity. It was their purpose, it was their meaning, it was their fulfillment. And it's something that as those scientists, when they created and they shared out with the world, what they get back from it is that feeling of purpose.
Yes.
And that is after your basic needs are met from Maslow's hierarchy of needs. Once they're met, there's the overwhelming thing of what is life, what is meaning, and finding where your element is more valuable than any number you could put in a piece of paper.
Purpose, finding purpose.
Yeah.
Finding the purpose. And then the downsides is now that we have internet and you get to see little small 10-second videos of people from all over the world, it makes you feel a little bit overwhelmed about what you're trying to do. Yeah. But just narrowing it down on something that truly gives you purpose, and the rest of it just shines through.
Yeah, I love that.
Yeah.
All right, we got to get into the nitty gritty of mandrels here, because Damian and I think in our first conversation had maybe a little tiny miscommunication on my end of tapered mandrels. I was kind of giving an overview of our capabilities and explaining, what we did, and that we supply, these quick turn mandrels. We have in stock mandrels that we ship same day, but we fabricate them. We can ship them in 2 days, like for just a prototype. And you said something. This is not direct quote. You can correct me. But like, oh yeah, I'm kind of against tapered mandrels. You didn't say that, but that's what I heard. And then when we were at the last show, I was like, can we circle back when we get together? Because I'm like looking at this print that's a tapered mandrel, and we're getting more and more requests for these every week. But the catheter guy doesn't like tapered mandrels. This is going to be a struggle for me emotionally. So tell me what you meant by that. And Mark, I can't remember what part of that conversation you heard, but what are some of the issues and challenges you're seeing from a tapered mandrel design perspective?
So interestingly, we actually have the same frustration with tapered mandrels, and that was when you're treating a tapered mandrel like a stepped mandrel. Mm-hmm. So one thing a lot of people wouldn't have been aware of is that there is an etch angle on PTFE where a lot of these tapered mandrels are used. And that etch angle, I know for Zeus, it's around 30 degrees. So if you use a very short, steep taper, you offset that's taper angle, and then basically when the plastic melts down, it comes straight back up, it delaminates, and then people are wondering why the device is delaminating. And what really you should be using the taper mandrel for is elongating and lengthening out that taper, so that you're not affecting that taper angle, so that etching angle as much. Yeah. So I think it's the same thing we're looking for.
Well, yeah. So you're seeing kind of the result of the finished product, the effect of the finished product when it's kind of that faulty design. From like the manufacturing side of making the mandrel, there are some challenges.
There are some challenges.
Same problem.
Yeah, you've got two sides on the when there's a really, really long taper, it's very difficult to gauge. So at that point, we put measurements on it, but finding where those transitions start is a challenge. When you make it really, really short, other than a step, right? A step you can deal with from a plunge grind. You can deal with that a little easier from the manufacturing standpoint. The minute you get into some really, really short transition, let's just say that you want a transition over 30 thousandths or something. Manufacturing, that grinding process can cause a lot of challenges in holding specs on that. And so it really is not a great, it can be done, but it's not, it's kind of like we can do it, we just don't like to, right? And it just causes a lot of challenges that I think are unnecessary. And when I hear you talk about the reasons why it does, especially in catheter production, it is unnecessary. And I think understanding the differences from a design standpoint of when I really need a transition versus I just need a step. I need a step. I'm trying to reduce the diameter here, the ID here.
So is that the problem? Is they're trying to use a taper where a step would do the trick?
No, it's that they're using too short of a taper, and then there's an issue with the output, and then they blame They don't know where to put the blame, right. But it's just that I've seen too many of them used incorrectly, and then the issues that fall out afterwards.
Okay.
And then usually it's in production when you get it, because when you're making the small samples, it's okay if you get 5-10% of them wrong because of that issue. But when that goes into production and it starts creeping in, and then once it goes through sterilization and a 4-year shelf life, then you start seeing a lot of problems coming back. So it's just the misuse of mandrels, not the mandrels themselves. Yeah. Tapered mandrels are incredible. And this is specifically for when you're using a PTFE liner to step down between two sides.
Right.
That, and as you're stretching a PTFE liner from one diameter to another diameter, it has a taper.
Yeah.
If your tapered mandrel is shorter than that taper, then you're basically just leaving a void where the plastic can't squeeze and compress down.
Yeah. So it's something that's good for us to know as we're seeing these designs in the beginning, to just be able to give that advice, give the feedback to them. Like this might work because we just need 3, we need them in 2 days. So very doable, but just making sure they're aware of the potential output problem later on. So that's good advice for us at the beginning, or any mandrel manufacturer,
right,
to keep in mind.
And a very simple goal, and I'm going to speak in millimeters here, so apologies, but if we're going from 2 millimeters to 1 millimeter, so you're going down by half. If you just figure out what the angle is to go down at that, and then design your taper around that, rather than just the engineering mindset was, if we make this as short as possible, we get to have more real estate on either end, and in theory, the process is simpler.
Okay.
But in reality, there's always going to be an angle where a jacket or a liner is going down from one side to the other.
Gotcha.
And just take that into account.
Okay.
So it's simple pains that you tend to learn the hard way.
Yeah, for sure.
Well, if you kind of, the subcontext here in this conversation is, you've got somebody who's going to make a mandrel, right? They're going to do the grinding for you, but then you've got all the other components, right? You've got the shrink tubing, you've got the etched lining, you've got all of these things. The encouragement here, I think you'd agree, is as a designer, just call us, talk to us. Call all of us. Yeah. Call us that we're going to grind this part. Call Zeus. Call whoever's going to make an etched line or whatever that, and just talk to us, because we don't really. I don't deal with etched liners, but somebody making that doesn't deal with the grinding of the mandrels. So let's just get all of us on the phone and let's try and figure out the best option for what you're trying to accomplish. Don't be afraid to call us. We like conversations.
And probably the most unengineering skill set that I have is the ability to ask really stupid questions confidently.
Oh,
yeah, that's.
That's why we've started on the podcast doing, we'll just get the conversations that we have on our online chat and just answer those questions, because we really believe there's no such thing as a stupid question. Sometimes you just got to get it out, get the stupid idea out, get the stupid question out, just get it, let it hang there for a little bit. And then, that's one obstacle, but we ask stupid questions all the time. Well, we think they should be asked.
There's that whole thing of kind of the idea of, man, I wish I was the smartest guy in the room. And we talk about that here. And we've kind of said, hey, listen, the smartest person in the room is the one who knows when it's time to open their mouth and ask another question. That's the smartest person in the room. And if we can define that for everybody, then now by asking the questions, it's a badge of honor.
And the way I actually looked at it, so what's that line? If you're the smartest person in the room, you're in the wrong room.
Oh, I love that.
So I always had a belief that almost like a game where you have 100 points and you put them over the different skills and abilities. I've always seen people that they have a certain amount of points that spread out between different skill sets. So I have never once in my life met someone who isn't smarter than me. And then all the goal is just figuring out what their skill set is, what their abilities are, and talking about their interests. And the stuff that you learn is incredible.
Yeah. It's one of the fun things about building teams is figuring out the gifts of the people that you're working with and, multiplying those or encouraging those and building those up. I think that's a fun treat and something I'm sure you find in your workshops. I bet people discover things about themselves in those workshops that they didn't know. Once you've unveiled kind of this mystery that's intimidating to them, once they're built with that confidence, they have room now in their brain to think about what they're actually good at. They're not intimidated. You've removed the mystery of the catheter.
That is the goal entirely, is just demystify all those things that seem overwhelming at first glance. And I always compare it back to when you go on holidays. And if you go to some place for the very first time, if it's a new country, new language, food can be a little bit overwhelming. You go back the second time, you're a little bit more familiar with it. And then the third time you feel at home and you actually relax.
Right.
So similarly with designing catheters and the equipment you use, if someone else shows you this is the equipment, this is where tapered mandrels are used, this is the outcome of them, this is the issues that happen. Yeah. When you find out you need to use one, all that's in the back of your head and you're like, okay, if this pops up, it's not going to be scary, it's not going to be new, it's not the first time I've heard about it. And so much easier to innovate there on.
Yeah. And whether intentional or not, you're creating, a community of people. You're not just giving them tools they need. You're not just giving them education. You're giving them a community where they can come and ask questions. They meet someone in the workshop. They see someone through your LinkedIn communication, and they find a commonality, and they have another resource just through the human aspect, which I think, sometimes we miss in the world of AI, which has great things, or the world of email, and we miss some of the human. And so I love that you do workshops remotely too, but the in-person ones, I think, are probably just such a special gift to everyone who comes, because they get the education and the community.
All my workshops are actually in person. I don't do any of them remote, because you miss out on so much.
Oh, I love that.
It's so hard to gauge or be engaged unless you're in the room physically holding the devices, the samples, the materials. And I think our industry versus other industries, so if you look at sports or media like that, there is such a big networking aspect to it. Yet in our industry, we love staying at home away from people.
Yeah.
Lock us in a room and just give us tools and let us create. Yeah. And that's where we're happy. So yes, creating some form of platform, I am not going to take credit for it all. People do that all themselves. Yeah. But if I can get a few people in the room to friends out of it, that is remarkable.
Yeah. Sometimes we just need the invitation, and the rest of it takes care of itself. So I love that. Okay. I think I have one more for you. This is kind of, actually maybe two more, and then we'll let you get back to designing very important things. Okay. I don't know if you can see this. I can read it to you. Okay.
Yes. We offer 3 kinds of service: good, cheap, and fast. You can buy 2.
We saw this sign. We saw this sign when we had a customer visit recently, and we printed them out and put them all over the office because we just think it's so funny. So what would you say in the early phases that you're in, if you can pick, good and cheap, but not fast, fast and good, but not cheap, cheap and fast, but not good. In the beginning stages, what do you think is the priority? And at some point, does it change? And when does that change?
So your initial devices do not need to be perfect. So it is quality, speed, or quality, time, and cost is what that sign is spreading out. So if the quality is not absolutely perfect, I would have gone for so I would have said cost and time. Yeah. But that was more of how I can make something into my hands today. Like that first
prototype. That's what we see too, just to validate you. It doesn't, sometimes it's I'll just need 2 of them. I don't need it to be exact, or they'll call out so many specs and we'll be like, well, which ones are the critical? And they're like, just that one. We can deal with the rest of it later. So yes, I totally agree with you.
And that's it. And I think when I'd done critical inspections on any of the specs that I sent out, there may have only been, even when I designed jigs and fixtures and equipment, there may have only been 2 or 3 in the space of making 10 different components. And it's the rest of it, if there's any little problems, I'll get a piece of sandpaper or a file and I'll fix it myself. Yeah. But if I can get it, and relatively cheaply, but coming from a farming household, cost was something that if I wanted something, the idea was I make it myself.
Yeah. Yeah.
And that is always the mentality I had. So the cost stuff was a little bit an oversight in my head. Yeah. But if I did need something quick, I think the beauty I found within medtech is that you can afford to get those components in. Yeah. Whereas in other industries, there was so much stress and pressure about this has to work first time. There's no second chances. Yeah. You order it in. If anything is wrong, you're not sleeping for a few days to get it fixed.
Right. Yeah, yeah. And we see that a lot too. If someone calls out, it's something very more complicated or the specs are perfect. We're like, we maybe can't do this in a day or two. Give us a week or 2. It might take a little longer if you can wait, or the quantity is a little higher. Maybe they've gotten that initial prototype and it's an iteration or something like that. But yeah, that's exactly what we see too.
There's a big thing too where if companies send out a spec, they look at previous specs to see what was marked as a critical dimension and mark that down without realizing the need, or if there is even a need for that critical inspection.
Right. Yes, everything is critical until it's really expensive, and then they're like, well, we don't really need that.
Yeah, absolutely. Is it relevant at all to what you're doing? Yes. Now, when you're going for ordering 200, 1,000 or up to those kind of quantities, there's going to be bits that are critical. Yeah. But if you're ordering 2 or 3, what do you really need to get out of here?
Yeah. Yeah. And usually I feel like once you're scaling a little bit, you can create some efficiencies, and that can help your cost too. There's a sweet spot in quantity where you can start to offer price breaks, and it and just because you're making so many, you get in the routine. Sometimes it's just the tooling of that first one that's wrapped up in that cost. So it seems like maybe kind of expensive on the front end. You're getting it fast, it's a little bit expensive, but then that's just a one-time tooling fee or something. Once you get going, that's not going to be included anymore. Do you have any other questions or things that you want to talk about?
There's another note on that too, where it's a crossover from the business world, where the employees that you have that bring you up to the first 50 employees are not the same employees you have that bring you up to 500 employees. So similarly, when we are making stuff in medtech, those components, those tools, jigs, fixtures, the ones that we get the first 100 units of, are not the same jigs and fixtures, hopefully, fingers crossed, that you're using to manufacture 1 million units a year.
Yes.
Right.
They should be changing, and understanding that they are going to change and that it doesn't have to be 100% perfect from the start, because that does just slow down the process.
Yeah, I love that. Don't let perfection be the enemy of good.
Yeah, right.
So in the beginning.
Absolutely.
Yeah. Okay. Did you have anything else you wanted to ask?
I'm having so much fun though. This has been, it's hard to, like, if I get started, it could, this is going to be a 6-hour.
I know, so much for bits and pieces. It's a long one, but I love it. Damian, it's such a pleasure to have you on. Thank you so much. Did you have any questions for us or anything, any final words, final notes?
I'd like to know, is there any new components and stuff that you start seeing that customers are reaching out for that may have not have had a previous requirement? So there's always niche little things that I see people using, essentially old technologies in new ways, and obviously don't give away any trade secrets or companies' information.
No, we don't. From the component standpoint, we get requests for, and your team could probably answer more than this than I can because they talk to the customers. A lot of times what we find is that it's good for us to look outside of medical device for products because there's just crossover, right? You go back, years and years and years ago, they, engineers in this space looked at the lapidary industry for tools, right? So they were looking at the jewelry industry for tooling because those precision tools were really, really nice. We don't think about that today, but that's kind of where they came from. They didn't start out in the medical device world. They started out with people making jewelry. So we kind of look for some of those outside places. It's hard for a company today. My background was small parts incorporated in Miami, Florida. That was easier. It had a lot of different, because it had materials, components, and tools. It had lots of products. Mm-hmm. Component supply is a little more focused right now, just because other people popped up and did such a good job in specific areas that, for us to do it didn't really make sense. There were companies that did a good job. So in our specific field right now, I don't know that anybody's coming to us with, honestly, a lot new. It's shapes, it's designs. They're asking us to probably the big thing that people are asking, I would say, is we do get requests for like flat wires. Shaped wires. That's a very difficult product to standardize. So, and then put on the shelf, which is what we do, right? And so it kind of breaks our heart, hurts our feelings a little bit, if you want to say, because we still feel it is our responsibility to have products for people to test with in small quantities, but. If I picked 30 different shaped profiled wires, I'd pick all 30 wrong.
Now, that being said, we have had a customer or two need like a flattened wire, and we will take it in our shop and flatten that sucker because they just need one piece. And, we're like, this isn't efficient. This is just for you to test. And then we can point you in the right direction for someone who can do this, to spec. So that is one. And I would say, like, sometimes we get, so just in like full disclosure, we had a customer visit recently, big organization. The people we were working with did not know what the component was for, right? Like, these organizations are so big. The left hand does not know what the right hand is doing. They are trying to source this material. They're trying to make a model for this finished device. They're needing a tool for that. So a lot of that, like, we do consider ourselves tool makers. We're often using a wire to make some kind of tool. I don't know if what it's being used for at the end of the day. The person I'm doing it for is not even the end user. Their organization is so huge. I will say, we have gotten more requests for tapered mandrels than we have ever, really. And
tips,
and the
tip
tips.
Geometries as well.
And then finally, lots of inquiries about various coatings. So we stock off the shelf, like the Glide Med coating from Surface Solutions Groups, some of those variations, and our just regular PTFE. But I think as people get nervous about the use of PTFE, they're trying to move in that direction, because when is that going to actually play out? So that's kind of the question there. So those are lots of inquiries about various things, more than like a product design that we haven't seen before. So.
Absolutely brilliant. And Mark, you did lean onto something that I figured out quite a number of years ago, which is jewelry design tools.
Yes, right.
A lot of the tools that I have behind me came from the jewelry industry. I was actually shocked to find out that jewelers isn't a great wage. So because of that, the tooling that they use is actually very low cost. So getting jewelry tooling in, watchmaking tools, placement links for stone placement, it's incredible. And I even have a jeweler's roller to go making my own shaped wire whenever I need to.
So do we, yes.
Which brings us to the next question. Is there any piece of equipment you have that you really wish you would love to use more, that can have some capability on developing different types of mandrels, that you just wish it was turned on a little bit more?
We have,
yes. Mark is always trying to find an excuse to buy more equipment.
Well, no. We have a lot of grinders. So we like, grinding, centerless grinding, and as well as the tip grinders. Those are areas that we try and work, machines that we try and use a good bit. We love the person that comes and says, "Hey, we have an idea. Can you make 5?" And that's, and it's something that's not just standard, right? It's a little different. It's a little off. And so those are the things our team thrives on. Now, we would love it when somebody says, "Can you make 1,000 of the same thing?" Because it's good for business. But the grinding side of component supply has just gotten something we've put a lot of effort into, both from training and equipment. And so I'd love to see more of those those machines working more and more.
And one question on that, so it's something that I know answers for from various different suppliers, is the maximum length that could be ground, whether that's based on the bar stock material, on the limitations of the equipment, or the limitations of shipping. So what would be the maximum length you typically send?
Oh, yeah.
So, we have currently, as of this morning, I'm working with one of our grinders on a. I think the grind length is like 72 inches. Now that's a whole process, because we have to turn, we have to straighten the wire to a certain length that's longer than typical, and then turn around and do the grind. So it's doable in very long lengths. Typically, when you look at the kind of the typical machines that are out there today, you got about a 35, let's just call it safely, a 35-inch length in terms of the grind length before it has to do something. And there are other machines that can do it. They give up some not efficiency, but it gives up some of the controls. But 35 inches is a very safe, if you can keep it under 35 inches, that's a safe length. But it's not that it's not doable. We've done it, we're doing them longer. But if you can, keep it under 30, it'll keep your cost down.
And people are going to come up to you with 74 inches after this.
Of course they are. Of course they're going to do that. And that's okay. We'll, our job is to get in there and figure it out. So...
And the other side that I knew was a limitation was there was companies that would only send, I think it was actually 72 inches, because anything after that, the shipping cost was phenomenal.
Well, actually, interestingly enough, like for everyone to know, that changes at 48 inches. And when I say 48 inches, just so everyone in the world knows, it changes at 48.25 inches. So whether it's 48 inches or 76 inches, it doesn't really matter at that point. Once you hit, now the real limitation is the minute you get, depending on the shipper, once you get above like 84 inches, you got to put it on a truck. And that's where it can really throw you off. Others are maybe like 100 inches, but the minute you have to then put it on a truck, now you have a real problem. So what I would suggest for people who genuinely need longer lengths, and let's just say longer lengths are greater than 75 inches, call us. There are some options for shipping. We can try and figure that out. But the length is a problem. Just know that the minute you hit over 48 inches. So if you needed a piece of shrink tubing that was had a length of 48 inches, that's going to go in a 49-inch box. Right. It's going to be the same price as sending you a 72-inch tube, for your mandrel.
Yeah.
And then, is there any little neat tricks where you could have a bore and a thread on it, so you could actually get that mandrel in two pieces to reduce it down? But that little outside of the box thinking, I know it's not.
I don't. It's interesting. So much of that is, unfortunately, and it's possible, right? But now you've jumped into not only a grinding company. Now you have to have a turning. You got to have somebody with a screw machine to be able to turn those threads. That's sometimes it's the same place. A lot of times it's not.
And you don't have that perfect surface finish on the mandrel too.
And then you've got a transition there, and there's some potential problems. Not that you can't overcome it, but I'm not saying that wouldn't be fun to make one day. That's
Just wait for it. We're going to have a purchase order for the machines we need for that. This is on you, Damian.
Yes, no, I will say that step definitely would become an issue in most cases. Trying to make it completely fluid would be something that my head's already planning out and going to consume a bit of my evening. But for the time being, I know it was an outlandish thought, but it was just something that I noticed I would have done in the past. I would have been looking for, the device is long, I need long.
Giving out some secrets here. No one has asked us to do this, and when we've suggested it, they panic. But if you let's take the same, 72-inch, or let's take a 100-inch mandrel, right, and put it in an 18 by 18 box or 20, and put a big coil around it. I'm not sure it gets a cast. We've actually put them in boxes before, let them sit there for 2 or 3 days, pulled them out, and it didn't put a cast into it. Now, obviously, you've got some limitations. The minute you jump up to, say, I don't know, like a 60, 70 thousandths, you could have a problem. Mm-hmm. But I think there may be some potential there in the shipping and saying, okay, well, this is a 30 thousandths, mandrel. It has a transition on it. Mm-hmm. It's long. Can we put it in an 18 by 18 inch box and then ship it that way? Mm-hmm. And that's but people have to kind of overcome the idea of but I want it straight. Mm-hmm. And I think that's a little bit on us to prove, hey, we can do it. But I thought I'd throw that, since you brought it up, I thought I'd throw it out here because nobody's taken us up on it yet.
Yeah, no, absolutely. Unfortunately for us, that you can pretty much just go from your knee to your brain and not much further. So we won't need too much of an extensive length when it comes to these types of mandrels.
Right. I hope not.
Never say that. And hopefully not needles of that length, because I do not know where they're going.
No, I know when we people visit us at the trade show booth and we have our tip grinds and our needles, and people who aren't in, they're in another part of medtech and they come by the booth and they say, are those little torture devices? Like, no, they're dispensing needles, or, they're moving something else. We're not trying to torture anybody. We're not those people.
We're not those people.
So. If you want those people, they're
go see that booth. Wait, that's not a good way to make friends.
Not at all, but there's a market for everything out there. We're not going to judge.
It's so true. It's so true. Damian, thank you so much for joining us on Bits and Pieces. We're so thrilled to know you and to know that you're a part of our industry. And I just appreciate this conversation so much. And hopefully there are many more to come.
It's incredible, and thank you very much for your energy in this space. You are the people who are making this community come closer and closer together, so thank you very much, guys.
I appreciate that. Now go change the world.